All right, so on Tuesday, we learned about adding, subtracting, and multiplying. And from your assignments, it looks like that was fairly easy for you. I know that the answer key was not ideal, so I tried to double check the answer key this time. What happened is that I had two assignments, one for regular algebra 2 and one for accelerated, and they looked very similar. And I did the problems for accelerated and put the answers on the algebra 2 page. So that did not work out very well, but we should be good to go today. So for today, we are going to learn to divide. And there are many, many different ways that you can write the division. So you can use like the old school, like elementary school division sign. You can use the fraction bar like we've been used to. You can actually write out f of x over g of x. This is sort of how a computer would write it. So like all in one line using the slash as the division, or you could use the word quotient, right? Or you could use the word quotient. So I'm happy to see division in each of these ways. So as we're thinking about division, I want us to think first about like what division looked like when we were in elementary school. So when we had like 210 divided by 4, right? 210 divided by 4. 4, you had to check like, okay, is it going to go into 2? No, it's not. So is it going to go into 21? Yes, it is. How many times? It's going to go in 5 times. And then you would say, okay, how many is left over, right? So we did 4 times 5, that would be 20. And we subtracted the 20 that we had already taken out. And we found the remainder, right? And then we brought down the 0 from before, right? And then we were like, okay, so then how many times does 4 go into 10? It goes in 2 times, right? It goes in 2 times, and then 4 times 2, that would be 8. And we have 2 left over, right? And so then we were like, okay, well, 2 doesn't work. And after a while, we started to put like decimal points and keep going, right? But for a while, we just circled this number and we put remainder 2, right? We put remainder 2. We said like, okay, that is our remainder. That's what's left over. And today, we're going to be dealing with remainders as well, but we are going to write them in a slightly different way. The way that we would write it is we're going to write 52 plus the remainder of 2 over what we needed to still divide it by, because remember that 2 hasn't been divided yet. The 2 is what was left over, so it's still divided by 4, right? 2 divided by 4. You might recognize that turns into 1/2. We have 52 plus 1/2, which would just be like 52.5, right? 52.5. The important piece that we're going to notice today is how the remainder turns into a fraction here. Right, so we'll do that at the end. Seems a little funky, but we will jump into it and let me know. Feel free to interrupt with questions. The other thing before we jump in, as you're getting started here, I would love to hear more people off mute today. If you are able to come off mute, it's just much easier to like interact in a normal classroom. If you can come off mute, totally understand if you can't, but if possible, that'd be awesome. Remember, if you're clicked into the Zoom screen, you can use the space bar, press and hold in order to come off mute. Otherwise, you can use the unmute button. Cool. All right, so we're going to learn to do what's called synthetic division today. I do want to change your problem, so if you by chance printed or wrote it down, go ahead and scribble out that f of x as it currently exists. And we are going to write this for our f of x, and our g of x is remaining the same, x minus 2. So go ahead and take a moment to write that down. We have a polynomial, x to the third plus x squared minus 5x minus 2. And g of x is x minus 2. So it's asking us, what is f of x over g of x, or f of x divided by g of x? So I'm going to go ahead and write that out in one long fraction. So f of x is x to the third plus x squared minus 5x minus 2. And g of x is on the bottom, x minus 2. Okay. Give me a thumbs up in your reactions bar or on the screen if you are good to go. Thanks, Antoine. I see you. Thanks, Elizabeth. Thanks, Amy. Cool. All right. So there are two things that we have to do in order to set up this problem. Okay. So the first thing that we have to do is we are going to take the denominator and we are going to switch the sign. So since I see x minus 2 here, I'm going to use positive 2. If it's x plus 2, I'd use negative 2. So I'm going to switch the sign and I'm going to put it right here to positive 2. I usually like put a box around it and then I draw this upside down division bar. So that's kind of how I write it. So first I take the denominator and I put it over here. Now I'm going to take the coefficients of the numerator, and I'm going to put them along the top, right? So coefficient meaning the number that is in front of it. So there is a number 1 in front of x to the third here. So I'm going to put a 1 right here. Those are my x to the third. Now I need to do x squared. How many x squareds do I have? I also have 1. How many, then I have to do x's would come next. How many x's do I have? I have negative 5 x's. So I'm going to put a negative 5. And finally, I have a negative 2 here, right? My number is negative 2. So I'm writing like a shorthand version of my equation, right? I don't have to write this when I'm doing it. So the next time that I do this problem, I might not write this here. You just have to write the denominator here in the box and then the coefficients here along the top. This is a part of the setup process. Do we have any questions about the setup process? Awesome. Okay. So now I'm going to actually start the division process. So the division process, the first thing that I do is I take the 1 and I pull it straight down like this, and I put the 1 underneath. Now I have to multiply this number over here, this number, the 2, that's my multiply number. I'm going to multiply 1 times 2, and I'm going to put that number right here. So I'm going to put it right here under the next one. We do this little dance. We go down, and then we go up and over at the same time. So down and then up and over. And then I add the 1 plus the 2 would give me 3. So 1 plus 2 gives me 3. And now I'm going to repeat that sort of dance step over again, right? So I'm going to do 3 times 2, which would be 6. We go up here. And now I'm going to do negative 5 plus 6 would be positive 1. Negative 5 plus 6, positive 1. Again, in order to get up here, I'm going to multiply. So 1 times 2 would be positive 2. And I'm going to add these together. Negative 2 plus 2 would give me 0. I've gotten to my last coefficient. So that's how I know that I'm done with my problem. I'm gonna go ahead and put a box around this right here. This is my remainder. Number 1 is my constant, like the number by itself. 3 would be x, and 1 would be x squared. So I like work my way backwards with like increasing exponents. So if there was another number, the next number would be x to the third. So when I write my answer, well, my remainder is 0, right? I don't have anything left over. So when I write my answer, I don't need to include this remainder, because it's like if I was doing like 8 divided by 4 and I got 2 and I wrote remainder 0, like that's not necessary. I don't need to write that. I would just write 8 divided by 4 is 2, right? So if my remainder is 0, I don't need to write it. But this over here is my remainder. I'm going to write my answer as 1x squared, so x squared, plus 3x, using plus because that 3 is positive, and then plus 1. And that would be my answer for this problem. So I would say that x to the third plus x squared minus 5x minus 2 divided by x minus 2 equals x squared minus 3x plus 1. This makes sense to me generally, because if I have something that starts with x to the third and I divide it out in x, right? If I divide it out in x, then I should have x squared left over. I had 3 x's, I divided out one of them, so I should have 2 left over. So my problem is going to start with x to the third. I'm going to put up a quick poll here. How do you feel? Does this make 0 sense? All the way up to, does this make sense totally? Awesome, totally. If you're feeling a 1 or a 2, I get you. We're going to do another problem. If you're feeling a 3 or 4, I'm glad to hear that. It looks like no one's feeling a 5 yet, so I'm glad to hear we'll have another example. Cool. Awesome. All right. Let's go ahead and do this next one here. Go ahead and write down this problem. So we have f of x equals x to the fourth minus x squared plus 5. And g of x equals x plus 3. And they're asking for the quotient. So I'm dividing again. So I'm going to have x to the fourth minus x squared plus 5 over x plus 3. So I have this setup process. Can someone come off mute or in the chat tell me what the first part of my setup process would be?
To take the 3 and put it on the line on the side.
Yes, definitely. Go ahead, Antoine.
I was just gonna say the coefficient.
The coefficients. Oh, the coefficients are going to go on the other side.
Yeah.
Yeah, for sure. Is it going to be positive 3, Antoine, or negative 3?
Negative 3 because it changes.
Yes, negative 3. So we're going to take this number, we're going to flip it and put it here. I'm going to draw that upside down division bar here. And then as Antoine told me, I'm going to do the coefficients along the top. One thing to notice for this problem is that I have to do, when I write my coefficients, I have to write x to the fourth, then x to the third, then x squared, then x's, then numbers. But do I have any x to the thirds here? No, there's no x to the third in this problem. Thank you, Amy. There's no x to the thirds in this problem. So what I'm going to use is a placeholder. I use the number 0 as a placeholder. So when I write this, I'm actually going to write it as x to the fourth, 1x to the fourth, plus 0x to the third, minus 1x squared, plus 0x's, plus 5, like that. So I'm going to write each of those. I'm going to write all 5 of those coefficients. So my x to the 4th would be 1. My x to the 3rd would be 0. My x squared is -1. My x's are 0. And my constant is 5. So I want to use these placeholders here when I don't have, when it like jumps a degree. Cool. All right, first step is what? What was my first step? After setting it up, what's my first step?
You gotta bring the 1 down.
Bring the 1 down, perfect. So I'm gonna bring the 1 down, right? After I bring the 1 down, I'm gonna multiply times -3. So I get -1 times -3 would be -3. 0 plus -3 would be -3. So now I'm going to do -3 times this -3 over here, gives me +9. So I'd have -1 plus 9 is +8. I have +8 times -3 would be -24. The numbers start to get kind of big here. That's okay. 0 minus 24 will be -24. Now I need to do -24 times -3 to put here. I know it's going to be positive. 24 is 2 times 12. So that's like 2 times 3 would be 6. And then times that 12 would be 72. That's kind of how I break it down. You can also use a calculator or memorize that 3 times 4 is 72. And then 5 plus 72 would be 77. Oh yeah, thank you, Antoine, in the chat. Perfect. So this last number, what is this last number? Why am I putting a box around it?
It's the remainder.
This is my remainder, right? This is number, -24 is my number. 8 is my x's, x squared, and x to the 3rd, like so. So when I write my problem, I'm going to go ahead and write it as x to the 3rd minus 3x squared plus 8x minus 24. And then I'm not quite done yet. I still have that 77, and 77 did not get a chance to be divided. So 77 still needs to be divided. It is a positive number, so I'm going to write plus 77 over, and then my original denominator, x plus 3. So my original denominator turns into, is the same denominator that is in my problem here. All of these other things have been divided by that 3. But we did not do that process with the 77. So we need to note with our remainder that the 77 still needs to be divided by x plus 3. Right? We just can't do it without like messing up the fraction. So the remainder is written like this in the problem, or in the answer, I'm sorry. So this is my remainder. But that entire thing is going to be my answer to this problem here. Cool. Okay, I want to have you guys try one on your own. So if you see here where it says you try, you have x squared plus 5x plus 1 and x plus 3. I want you to go ahead and divide that, do f divided by g. Try that one on your own. I'll be back in about 90 seconds. is, let me know, and then we can go ahead and do another problem together if you'd like. I want to make sure we get your support. This is officially the end of our notes today. So if you'd like to get started on the assignment, you are more than welcome to. All right. Okay, Amy. Sounds good. Thanks for your message. If you're looking for the assignment, it is there. All right. I'll go ahead and do number one so that we can get any support that we need before we head out today. So for number one, I'm doing f of x divided by g of x. So I know x minus 2. I'm going to flip that into positive 2. And then I have my f of x here, my numerator. So I'm going to write my coefficients, starting with x squared. So 2x squared. How many x's? I have 3 of them. How many, what's my constant? It's negative 4. So my first step, always bring down this number here. So I have 2. 2 times 2 is 4. To go here. 3 plus 4, right? 3 plus 4 is 7. And then 7 times 2 is 14. Negative 4 plus 14 would be positive 10. This is going to be my remainder, my number, and my x. So I would have 2 x's plus 7 plus 10 over my original denominator was x minus 2. I'm going to have x minus 2. And I see that this matches the question that was here. So I know that I got it correct. So numbers 1 through 6 should be fairly standard. And then for number 7, that would be the first one where you have to use a placeholder. Awesome. All right, everyone. Welcome back. Welcome back from your breakout rooms. All right, I just wanted to highlight that this is the end of our class for today. Thank you so much for engaging with synthetic division today. If you have any questions, as always, you can send me a text message. It's usually the fastest way to get to me. If you're okay to wait, or if you just want to use email, you're welcome to use email as well. For today, you have 13 problems on paper, and then you have your Google checkpoint. There is extra credit at the bottom if that's what you're interested in. If you have any questions, please feel free to stick around. Otherwise, you're welcome to head out, and I will see you all later. Bye, Geraldine. Have a great day.
Bye, Miss. Hope you have a good day.
Bye, Antoine. You too. Bye, Nick. Bye, Anna. Bye, Amy. Hi, Liza. Is there, I think that says tutoring actually. There's not an official time, so if you need any help, just shoot me a text message. I can help. I can help during like your Spanish off time if you need to. Just send me a text or come back at 10:30. Either way. I don't know when you have Spanish. All right. Bye, Cheyenne. See you later.